Hello, everyone. Good morning. I would like to welcome you to today's presentation. We'll be looking at enhanced oil recovery using local surfactant material, an experimental approach. My name is Samuel Budede. This research was done for the completion of my undergraduate studies. Let's dive deep. We'll be looking at the introduction and challenges statement. We'll be looking at the methodology, result and discussion, conclusion, recommendation, and acknowledgement. The introduction. Now, here is an orange. When an orange is sliced with little or no pressure, we'll be able to get 20 to 25% of this orange dripping out with little or no effort. And this is a major concern. The same thing can be said to be looking at the reservoir. Immediately you drill through, the initial pressure comes out as a result of the gas. Once the gas pressure reduces, the possibility of having a natural drive depletes. About 20% of this, 20 to 25% of this hydrocarbon can be extracted at that point, and thereby leading to other means of recovery. Averagely, 25% of oil recovery from the ground leaves about 2/3. From what we looked at, it means 2/3 of it is being stocked in the subsurface. This happens to be a major concern to every producer or explorer out there, and there will be a greater means of improving the recovery, and this leads to the enhanced oil recovery. Our target is to develop a fluid that can aid the recovery of crude at a low possible cost while looking at the environment while having a less impact to the environment. Here is the overview of this. Now we get to realize that here we look at it, first of all, the primary recovery, the structural flow. Now, primary recovery is the first thing. And in primary recovery, like I said, the reservoir can have its natural flow and also can have an artificial flow, which is an example, a gas lift. A gas lift is a system that used to help the pressure, but is different from pressure maintenance. Now, the next one is secondary recovery. This happens to do with the aid of pressure maintenance or water flooding as the case goes by. And that will give us between 30 to 50% of our total recovery. Now, this is called improved oil recovery. Improved oil recovery comprises of both the secondary and the tertiary. Now, our main focus is the tertiary recovery, which is the EOR. And in the EOR section, we're focusing on the surfactant in order to scoop out a larger volume. Now, how do we do it? The reason is because we have to consider some few things. One, the viscosity, the specific gravity, the high price of surfactants, the excess surfactant absorber, excessive surfactant absorber, and instability under harsh conditions. These are the few things that we have to consider. And also, it's a major challenge when looking into the surfactant section. Now, what do we want to do and why do we want to look into surfactants? The reason why I want to do this is to maximize the hydrocarbon recovery. Why surfactants? Surfactant has an ability to generate foam. It is also, it boosts our recovery with low interfacial tension and mobility, the residual oil. Now it helps to change the wettability from the oil wet to a water wet. The reason of doing that, in the process of reducing surface tension, there is a greater possibility of change in wettability. And then emulsification is also done. All this reduces the surface tension, thereby enabling free flow of a desired hydrocarbon. Now, the way this was done at first, we prepared a pack, a sand pack. Now, the purpose of the sand pack was for us to establish our pore volume, the bulk volume, and porosity. And then we move over to the next thing of also testing our surfactants. Now, we have different leaves. We had to select some leaves. We'll see the names of the leaf in the next slide. Some of it is Moringa oleifera, Jatropha cacos, the bitter leaf, and other leaves that has surfactants found in them, saponin. So what we did was a fusion test and also an emulsion test to possibly identify this surfactant material. And then we have a core lab where this experiment was carried out for recovery. Now, after this was done, we got our samples. The samples we got, we first looked at the crude oil, and our crude oil density was 0.92, having a viscosity of 39 and an API of 25.88. Now, this tells us we know that the crude found in Niger Delta is they are basically light crude. We have medium and also ranging between medium and light in Niger Delta. That's Nigeria. And also the surfactant we use, like I mentioned, the Jatropha cacos, the Moringa oleifera, the bitter cola, bitter leaf, and STS, which is the conventional. So what we had to do was we did two different type of extraction with water and also an extraction with methanol. These were the following results, and also the densities were weighed also. Now, looking at our results, running through our results, we had to look at the displacement efficiency for a 2 pore volume, 1 pore volume, and also 0.5 pore volume. What we did was, after acquiring the pore volume of each of these cores, we flowed after doing the primary due to we injected this crude into the formation, so we move straight to the secondary recovery. And in the secondary recovery, we use water flooding, after which we have some percentage of the crude still there. So we had to do different iteration of 2%, the pore volume of this fluid, 1% of as in one of the pore volume, and also 0.5. Now we could see that yes, a 2% pore volume, the Jatropha cacos recovers a higher percentage of crude, and also 1% was okay, 0.1% was also lesser, that's in the hierarchy, and also Moringa oleifera also performed more with a 0.5% pore volume. The shea butter on its own, due to has also the same trend as the Jatropha cacos, having more of the pore volume at the higher ends. Now, we also looked at bitter leaf. A bitter leaf result was showing that yes, there is greater efficiency in the 0.5 pore volume. After looking at this in different range, we decided to carry out the experiment further, and in tabular form, looking at the results clearly, we have the initial and in place volume for each of these substance, and we could see the recovery from the water flooding from each of them. Thereby, we have more recovery found the in percentage in the conventional, followed by the bitter leaf and moringa with Jatropha cacos, and also the black soap. So at the end of the day, we had to quickly do a test run on this, and the result we saw here was that the recovery efficiency of the EOR was more, we have greater recovery with the Jatova Kakos, followed by the shea butter and the Moringa oleifera. So with the Moringa oleifera, those are the few things we looked into. So finally, we had to carry out the last um, thing. We looked at the combination of the secondary recovery and also the EOR. We could see that we have a greater recovery in volume compared to the oil in place in Jatova Kakos, followed by the shea butter and the conventional. So in hierarchy, our total recovery, the Jatova Kakos proved to be very efficient, followed by the shea butter and also the Moringa. After the Moringa, we have bitter leaf coming in last before the conventional. Now, this tells us the efficiency of this experiment. For the enhanced oil recovery process, which was done only with the saponin, the surfactant agent, we could see the same thing that was said. Jatropha cacos coming in top, solo that shea butter, and Moringa oleifera before the black soap. The black soap is a local soap made in Nigeria, and also the residual oil in place, telling us how efficient our work was. The Jatropha caustic comes up top, followed by the shea butter, before the Moringa oleifera and the black soap. In comparison with the conventional, which is the SDS, so what we have there is the same thing that has been said, the Jatropha still coming on top. So most of our observation, we observe that when the black, when local ethanol, that is in Nigeria, we call it kai kai, was used in the extraction process, we we observed that the crude flew to the top, and after a while, after 30 minutes, we saw that yes, it became more dense than water and then sank to the bottom. That was one observation. And this tells us that in the process of mixing, we have to ensure that the quantity of ethanol being used in subsurface product recovery should be monitored. And also, we also felt that in the process of application, we do not leave that to settle in the reservoir for a longer period of time. There was a change in the viscosity. A change in viscosity was observed after this extraction. This shows a reaction between the oil and also the surfactant, telling us that it works effectively, reducing this interfacial tension. And also this was done in room at a temperature of 60 degrees. And based on the condition of the shea butter, it must be because of its congeality, having both surfactant possibility and also um, a polymer attribute. It has to be heated to about 60 degrees before used. And also the sand pack was soaked with brine for 2 to 3 days to eliminate hair trapped bubbles. In conclusion, we come to realize that truly local surfactants has the capacity of oil recovery, and also surfactants can be made locally from local materials such as the bitter leaf Moringa oleifera, Jatova cacos. This shows that Moringa oleifera and Jatova cacos has a greater potential in oil recovery and also has the ability to reduce the surface tension and also act as an emulsifier. Surfactant material, like we said, can be used in this process. Further research has to be carried out. Our recommendation is further research can be carried out to actually understand the percentage of saponin being done. This was done locally, and I would like to push this up to a standardized lab where these tests can be done, and the percentage of saponin of each of these potentials can be determined and further used for the enhanced oil recovery process. Other pilot tests are required in subjecting it into reservoir condition for effective delivery and also efficiency of this. And also government and oil company partnership is highly encouraged for these purposes. I would like to acknowledge the Institute of Petroleum Studies, University of Port Harcourt, for giving me the opportunity to run my research in the lab there, and also my late supervisor, Dr. Ubani, C.E. Ubani, the head of the department. Also, Dr. Rigi Boniface, Professor Mike Oyekon, Professor Ajayinka, Joseph Ajayinka, and Dr. Tarako, Engineer Landa, Engineer Victor, for their contribution and also technical support. Also, Dr. Chidima and also Engineer Membre from SPDC Operations for their suggestions and idea. Thank you very much for your time and have a lovely day.